Hi there, so today we've got another way in which we can represent continuous data on a kind of a graph. This time it's a histogram, which looks like a bar chart, but isn't. If you remember bar charts going way back in the day, you will have had always evenly spaced bars and an even gap between the bars. Now if you look at the histogram that I've just sketched behind me, you may well notice that, as well as the fact that I haven't used a ruler, which of course I should have done, some of the bars are very narrow and some of them are very wide, and that is not a mistake. And there's also no gap between them. And also up the side, it doesn't say frequency, but it says frequency density, which means how closely together our data is coming in. This confuses a lot of people, which is why I've got that other little annotation there just above the bars, which says the frequency is the area of the bar. So if you multiply the frequency density by the width of it, you do get the frequency. But how do you work out the frequency density?
Right, so here's our first problem. Now, if you think you know what you're doing with histograms already, by all means, pause the video and give it a go. But otherwise, don't copy that table down yet, because I'm going to rearrange it. Generally, I prefer to have my table going the other way. If you're not sure what I mean by that, you will in a moment. Right, so here we go, and you'll notice I've added a couple of extra columns on. So first thing is, as you would have noticed, as we talked about before, some of the bars are different widths in a histogram. And if you look at this, from that's 5, that's 5, that's 5, but you can see I got a bit lost and numbered it a bit wrong when I was going through it. This is 10, and from 50 to 80 is bigger than that. So that's important, that is significant. If we just did frequency up the side, we would be making our bars misrepresentative. To any wider bar, it would look too significant because it would have width as well as height. So here, the class width there is just 5. 35 take 30 is 5. That's 5. 50 take 40 is 10. And 80 take 50 is 30. So those are my class widths. Now density, just as density in a physical substance is done by dividing one thing by another to say how much weight you're getting within a certain volume. Here we're going to find out how dense our frequency is by dividing it by the class width. So if you've got a very wide bar, it's not necessarily going to be very dense. So 55 divided by 5 is 11, and this is called frequency density. And you get it by doing the frequency divided by the class width. And then we're going to need 39 divided by 5, which is 7.8. 68 divided by 5, which is 13.6. 32 divided by 10 is nice and easy, 3.2. And 6 divided by 30 being 0.2. So, time to show what that looks like in your histogram. And here is the histogram. So you will notice how much wider these two bars are, and there's only 6 people in this, so the area of that 6 is the same as the area for any one that's within the others. But there was one more question. We had to estimate how many students took between 36 and 45 minutes. Now, if I were to draw that on the histogram, that's going to be, well, 36, so that a couple of millimeters in there. We're actually going to be talking about the number of students represented within all of that part of that bar, and 45 minutes is halfway across that bar, isn't it? So we need to work out both of those. So 36, so we've got 4/5 of from there to there, haven't we? The actual width from there to there is 4. So the frequency is the area, which is length times width for a rectangle, isn't it? So we've got 4 being the width there, times 13.6 was the height of this bar, the frequency density. And then we've also got this part here. Now this is 5 wide, and the frequency density there was 3.2. So we just have to pop that into the calculator, which should give us 70.4. So 70.4 is our answer, even though you can't have 70.4 students, but it's because it's an estimate, and therefore it shows that we are estimating it to be slightly closer to 70 than 71. So we'd expect 70 or 71. We're not exactly sure which, so 70.4 would be the answer there. Okay, now this is a kind of question that's very popular in our higher GCSE papers actually, so you may have seen something like this before. So pause the video, give it a go. And what you should notice is that although this frequency isn't completely filled in, we do know something about, say, this bar here, in fact, and this bar has been drawn. We know what the frequency density is. So we're going to need to work backwards a little bit here to fill in what these frequencies are first, then we can sort out drawing the final bar. So how would we do that? Well, we can think about what is the frequency density. So let's just add those on here. The frequency density there, that's 1, that must be 0.2, mustn't it? This must be 1. This one we don't know yet, but we do know that the frequency is 15. And the class width, if we think about that, the class width is 20 there, it's 10 there, it's 5 there, it's 5 there, it's 10 there, and it's from 50 to 70, 20 there. So we divide the frequency by the class width. 15 divided by 5 is not 5, it's 3, isn't it? So that means that we would need to draw in a bar at a height of 3, and that is all that's asking us to do from that point, from completing the histogram, but I think we need to complete this too. So if you divide going one way, you multiply to go the other, don't you? So 10 divided by 10 is 1, so 1 times 10 makes 10. We've got a frequency density here of 0.7. So 0.7 times 10 is 7, and here we've got halfway between there and there must be 0.3, and 0.3 times 20 is 6. So that does part A. Part B. Estimate the number of passengers delayed between 25 and 38 minutes. So the first thing I'm going to do is actually draw on here to from there and then up to 38. There's 5 little squares across, so that must be just cutting 1 square off. So this is similar to what we did before, which would give us a width of 5 there and a height of 1. So it's 5 times 1. Oh, hang on. I've missed a bit out there, haven't I? What about the 35 to 40? 25 divided by 5 is 5. So we need to draw another bit on. I'll just jump ahead and correct my mistakes. Okay, so from 35 to 40, that needs to be at 5, so that's just moved on up there. So I've still got those 5 people for there. In here, we already know that 30 to 35 is 15. And then we're also going to need the part from there to there. So that's going from 35 up to 38. So that's a bar width of 3. And the frequency density is 5, so that would be 3 times 15. So that's going to give us 5 plus 15 plus another 15, making 35 passengers. Okay, here's the kind of question we all love to hate in maths. One of those where it's talking about something and you just sort of imagine it, because it's talking about a histogram, but there is no histogram to be drawn as such. We have to think our way through it. So pause the video and see what you reckon. So first up, the reason to support the use of a histogram. Well, it's grouped frequency table, it's temperature. So what sort of data does that mean? It's continuous data. The data is continuous. That is all you need. I mean, it has also told us that it's in a grouped frequency table, so you could say that as well, because you always have a grouped frequency table to help you create it, but the data is continuous will be fine. Write down the underlying feature associated with each of the bars in a histogram. So what have they all got? What is it that makes them fair? It's the frequency density. What does the frequency density mean? It means that the area is proportional to the frequency within each one. Okay, next up, they're telling us that there's a rectangle for the class width from 16 to 18 was 3.2 centimeters high and 2 centimeters wide. Show that each day is represented by an area of 0.8 centimeters squared. So the days are the frequencies, aren't they? So this is a little confusing, because normally you'd think, right, the frequency 8 is divided by the class width 2. So it should have given us a 4 centimeter high one. But for whatever reasons of making the axis the way they wanted to, the heights turned out to be 3.2 centimeters. So you've got to say that the height, treat that as if it was the frequency density. So the frequency density is the frequency divided by the class width. So what have we got? We've got 3.2 centimeters is the height, because it's not really the frequency, is it? So we don't know what they're representing as. So we could call that x, couldn't we? Has been divided by 2. So 2 times 3.2 equals 6.4. So that is what we would then need to think of as the area of the bar, and the area, the area is representing the frequency, isn't it? So if we divide the area by 8, 6.4 divided by 8 is 0.8 centimeters squared per day. So we've shown it. You might want to run that back once or twice. Given that the total area under the histogram was 48 centimeters squared, find the total number of days in the sample. Well, every 0.8 is 1 day, isn't it? So 48 divided by 0.8, that's how many days we're going to have, because every 0.8 is worth that. So if you do 48 divided by 0.8, that comes out as a nice round 60 days. Okay, and now we're going to finish off with a more normal looking frequency density histogram problem. Right then, so we've got a fun day committee. Pause the video, give it a go. You may well find that taking a little print of the screenshot if you're able to, so you can draw on the histogram, may well help. So first question, it's just continuous data. Continuous data is the reason that it's suitable to represent it. And that's so the bars can run into each other, which they don't on discrete data. So a bar chart is for discrete data, a histogram is for continuous. It's just a 1-mark question, it's all you need. How many people entered the competition? Well, in order to do that, we need to start working out what the frequencies are. So the frequency density, so the frequency is the frequency density times the width. So you're going to have 2 times 20 plus would give us how many in that one, and we've got 5 times, well, that looks like 35, 15, and so on. And if we add all those up, we get to 310. Next up, estimating how many people threw between 30 and 40 meters. So it's time to do a little drawing on there, and we've got there to there. So I've just created 2 slimmer bars. So I'm going to have, there's just a gap of 5 from there to there. So that is 5 times 5 plus 5 wide again times how high is it? 10. So that gives us 25 plus 50, making 75 people, sorry. Very similar. How many people between 45 and 65? Well, we're just talking about from there to there, aren't we? So all we have to do is add up this bar and this bar, which is those 2 there, isn't it? So 6 times 15, which is 90, plus 5 for those gives us 95. And how many through less than 25? Well, all we've got to do is we've got this lot here, which is 2 times 20, making 40, and then we've got that bit there, it's 5 wide, and it's 5 high again, so it's 25 for there. 40 plus 25, sorry, gives us 65 as our final answer. And I hope that made sense. You may want to go through and do it again if it didn't. Cheerio, until next time.